Modern software applications are often built out of loosely coupled microservices. These services can be written in different languages by different people, but communication between the services needs to be standardized. For this reason, a service proxy is useful. A service proxy is a sidecar container that sits next to a service and facilitates communications with other services. Once every service has a sidecar proxy, that sidecar can be used as a way to communicate with a centralized control plane. The sidecar can report telemetry data to the control plane, and the control plane can be used to set policies across services, such as rules for scaling and load balancing, which might vary from service to service. Istio is an open platform to connect, manage, and secure microservices. Istio is a service mesh that uses Envoy service proxies. If all of this sounds confusing, don't worry, we'll explain it all in today's interview with Varun Talwar and Louis Ryan, who both work on Istio at Google. And if you're looking for old episodes of Software Engineering Daily and you don't know how to find the ones that are interesting to you, you can check out our new topic feeds, which are in iTunes or wherever you find your podcasts. We've sorted all 500 of our old episodes into categories like business and blockchain and cloud engineering, JavaScript, machine learning. We've got a feed with the greatest hits of Software Engineering Daily, so if you're having trouble parsing the feed for the episodes worth listening to, greatest hits is a good place to start. So whatever specific area of software you're curious about, we have a feed for you. You can check the show notes for more details about these new topic feeds, and I'd love to hear your feedback on them. I hope you like this episode. Your application sits on layers of dynamic infrastructure and supporting services. Datadog brings you visibility into every part of your infrastructure, plus APM for monitoring your application's performance. Dashboarding, collaboration tools, and alerts let you develop your own workflow for observability and incident response. Datadog integrates seamlessly with all of your apps and systems, from Slack to Amazon Web Services, so you can get visibility in minutes. Go to softwareengineeringdaily.com/Datadog to get started with Datadog and get a free t-shirt. With full observability, distributed tracing, and customizable visualizations, Datadog is loved and trusted by thousands of enterprises, including Salesforce, PagerDuty, and Zendesk. If you haven't tried Datadog at your company or on your side project, go to softwareengineeringdaily.com/Datadog to support Software Engineering Daily and get a free t-shirt. Our deepest thanks to Datadog for being a new sponsor of Software Engineering Daily. It is only with the help of sponsors like you that this show is successful. So thanks again. Varun Talwar and Louis Ryan work at Google. They're currently working on the Istio service mesh project, which we're going to discuss in this episode. Guys, welcome to Software Engineering Daily.
Hey, thanks, Jeff.
Thanks, Jeff.
So today we're going to talk about the service mesh, and this is something that comes up related to Docker and Kubernetes. And first we should motivate a little bit about kind of the issues that develop when a company moves their application from a monolith to microservices. Maybe they're running their microservices on Kubernetes, and there are these communication issues that develop when you have these different services communicating with each other. And I guess not just communication issues, but problems of the holistic application that's running across Kubernetes, where you want to have some centralized functionality across those services, in addition to having the individual services being decoupled from one another. So maybe you could talk about some of those issues in communications and the overall health of an application that are not taken care of just by virtue of the fact that you have moved your application to microservices on Kubernetes.
Right. So, I mean, the most obvious thing that, when you turn a monolithic application into a distributed system, your network is going to break. It's, people like to refer to it as the fallacy of, permanent network availability. It's a real thing. It happens an awful lot. It happens in surprising ways. The mechanisms that you were using before in your monolithic application, are harder to make occur again when you have this distribution. You're used to using consolidated logging, or you're used to using exception handling and writing retry loops that way. But when the functionality is spread across all these disparate processes, the scope of failure modes increases pretty dramatically. Not just that calls simply fail, you also have to deal with the fact that calls may partially succeed, which is almost a harder thing to deal with. And what's happening as you're breaking the monolith apart, what's also often happening is you're also becoming more polyglot. And so the programming practices that you used to have in one monolith don't apply anymore. People are using different programming practices. You've broken responsibility across many teams. And so, you don't have this uniform tool set to start working or corralling these behaviors again. And so it can become extremely expensive to kind of recreate some of the standard management practices that you used to have in the monolith in this distributed system. And so what Service Mesh is attempting to do is to say, look, there are these application level concerns around, traffic reliability, around observability, that you've essentially moved over into the networking layer, but you haven't figured out how to standardize support for them yet. And so the Service Mesh is trying to do that for you. Mm-hmm. It's trying to give you effectively a whole bunch of behaviors that appear like they're part of the network, and it doesn't really matter how they're implemented, but that you can rely on them to improve the reliability and behavior of your distributed system.
Mm-hmm. I think I can break down what you just said into two broad categories, which is that you want some increased reliability / observability / richness of features, distributed logging, for example, aggregating logs instead of getting them all from one place, a monolith. And then you also want this standardization, because you have a polyglot system. How are we going to standardize how these different things are communicating with each other? And I think the latter of those two problems we addressed in a show that I did with Matt Klein from Lyft. He built Envoy, which is a service proxy that is heavily used within the Istio service mesh that we're going to discuss. Explain what a service proxy is.
A service proxy is, this piece of functionality that is attached to your application. We attach it to the application because effectively it's acting on behalf of the application. So people often use the term sidecar proxy because this proxy is effectively deployed along with your application logically. It's like a tool that the application is using. Ideally, maybe the application doesn't even know that it's using this tool, but it's a bridge between the application and the physical network that adds in all these additional capabilities. One of the reasons why we deploy it as a sidecar proxy rather than maybe as the more traditional middle proxy architecture that people might be used to is because this proxy is acting on behalf of the application. One of the features it's going to provide is it's going to act using the identity of the application. And that often means credential distribution. It means that it has access to secrets that represent the identity of the workload on behalf of whom it's going to be performing certain actions. And so from a security perspective, you want to make sure that you don't have confused deputy problems. It's very much easier using the sidecar model to make sure that that doesn't occur. So now that you have this sidecar proxy, it's sitting next to your application. It's part of the application logically, even though it may actually be a separate process. And all the application traffic is flowing through it. It can start to do a lot of these functions that I just talked about, that you mentioned, improving reliability, increasing observability.
To add to that, just to explain, I guess, new users, this model of a co-process or a process sitting next to the application and basically acting on behalf, as Louis said, is what makes this possible in, independent of language. So that's what gets to the polyglot story of no matter what your application is written in, this process can do a bunch of reliability, observability things on your behalf. And I think the other one being, since it's sitting next to the application, can use the application identity to on all sort of outbound traffic from that application. And you do that in where you get uniformity and consistency is when every service in the application, the overall system, is using the same way. And that's when those combined together is what we call the service mesh.
Right. To give a finer point, to reiterate what you both just said about the service proxy, it sits in a sidecar, which is a term used to describe, in this case, a container that sits alongside another container in a pod. So in Kubernetes, you have pods, and a pod is like an abstraction. Am I phrasing that correctly?
Yeah, so that, in the context of Kubernetes, that's typically how we would run. There are obviously other deployment vehicles. You may just have your service running on VMs, in which case, the service proxy would run as a sidecar, another process next to whatever other processes are running inside that VM.
Right. The main thing to focus on, I guess, is the locality of this sidecar, because the sidecar is close to the service, because the service, whenever the service, in a microservices architecture, you're going to want to communicate between services a lot. You have these service calls that go from service to service to service in order to fully fulfill the user's request. And when you have these different services communicating with each other, it's useful to have this standardization. So you have, every time a service is going to communicate with another service, you have it speak through the proxy, and one proxied service point will talk to another proxy rather than the services talking directly to each other. And then because every service has basically this, microphone that it's talking through to other services, you can have those microphones talk to each other, and basically that's the service mesh, and all those different sidecars can report back information to a centralized place. So explain what that centralization, I think that centralization or that collection of information, that's what defines the service mesh. So talk more about what we have architecturally in addition to these sidecar service proxies that we would talk about as the service mesh.
Right. So there's the proxies provide, what we would typically term the data plane, right? They sit between the services. The traffic flows through the proxies as it moves between service to service. And the proxies do two basic functions. They make sure that the traffic flows well and reliably. And then they also extract features out of that traffic that then you could use to start, enforcing policy on, or, gaining insight into the behavior of the mesh by adding observability to. So what the proxies do in Istio today is they make calls to a centralized service that's effectively taking these signals and emitting policy decisions back into the data plane. One of the reasons you want centralization is, particularly of policy, right, is that as an operator, right, when you're managing a service mesh, there's a variety of things that you want to achieve in a common way, no matter what service is talking to what other service. Maybe you have an investment in an existing APM vendor or logs provider, and you want to make sure that every service, all their logs are going into the right location. The mesh can help facilitate that because it gives you this centralized point of control where you could send logs or telemetry data. Perhaps more interesting in the long run for people, though, is, as your deployments become more complicated, you want to enforce policies around which services are allowed to talk to which other services, what types of traffic are allowed to flow between those services. And not just services, maybe between physical locations. Maybe you have some compliance requirements. As long as you can guarantee that those policies that you want to enforce are being respected by the services, then you have a high confidence that you're meeting your organizational goals. So the mesh enables you to do that type of thing because it has given you this uniform way to interpose into traffic. You can reliably know that your traffic is conforming to those organizational policies. And usually those organizational policies are managed centrally. So we have a component in Istio called the mixer, which is where really the kind of the mesh or cluster operator goes and defines those policies, plugs in integrations into downstream systems, whether it's a logs collection system, a telemetry system, Or maybe it's an ACL system, like maybe you want to write an integration into Active Directory or something like that. And you want to manage this centrally because these are cross-cutting concerns, right? They are things that operators or SRE roles in your company are responsible for. Maybe you have to do audit or compliance reporting for CIO. You want to make sure that you're covering these things. And you don't want to have to do that for every process or every piece of application that's running in your data center or on-premise or in the cloud. And so this gives you a way to start to roll out those types of things.
So examples of problems that you might solve by policy, would these be things like security and load balancing and monitoring and rate limiting?
We try to be careful how we use the term policy because it can be, it's an overly broad term unless you're a little careful how you use it. We tend to think of policy as things like quota and ACL. Organizational policy, there's things like compliance requirements. So it's hard to say that auditing is a policy per se in the kind of runtime sense, but it's a policy that your organization might have that you must audit. So we try to separate runtime policy, things that affect the behavior of services then when they talk to each other, and policies that your organization is trying to achieve or ensure compliance with. They're slightly different things, but when we use an umbrella term, we do tend to use the term policy to describe those types of things. Telemetry is a little bit different. Telemetry is usually its own consideration. People tend not to refer to telemetry as policy. So we tend to use slightly different terminology when we talk about that. But effectively, it's, from an organizational policy perspective, you want to make sure that you're doing all of these things. And that's what this really helps you achieve, right? It helps you achieve consistency of all of those cross-cutting concerns across the entire fleet without having to go and modify every single application in the fleet to make that happen.
To add to that, to both your previous question, sort of why centralization and what problems that solves, I think one of the things that has happening with this, I want to break monolith into microservices, that's great, agility for each dev team. What we're trying to do with Service Mesh is saying, hey, what about the DevOps team and the SRE team, right? That's usually not given, sort of associated with every team. There's typically managing the overall system across the organization. So in terms of, I think there's two answers to why centralization, like one uniform tool set, so to speak, for the DevOps and SRE folks. And that is the injection point for either runtime policy or org-wide policy. And the second piece is one point of integration for telemetry. Now, even though you have N teams building in N languages and services, and you want to give them that freedom of, evolving those at their own pace and building in with the architecture they want, you still want to have a unified view of end-to-end latency and metrics, and you wouldn't want to have N integrations into monitoring systems done by each of those N teams. So basically, the other piece that centralization gives you is one point of integration, and that helps from standardizing the nouns that the entire team is seeing around the metrics, as well as, the call chain problem of like service to service to service and then debugging those.
Angular, React, Vue, Knockout. The forecast calls for a flurry of frameworks, making it hard to decide which to use. Or maybe you already have a preferred JavaScript framework, but you want to try out a new one. Wijmo and Grape City bring you the How to Choose the Best JavaScript Framework for Your Team ebook. In this free ebook, you'll learn about JavaScript frameworks. You'll learn about software design patterns, and you'll learn about the advantage of using frameworks with UI libraries like Wijmo. You'll also learn about the basic history and the purposes of JavaScript's top frameworks. You'll also learn how to integrate a Wijmo UI control in pure JavaScript and in some of the top JavaScript frameworks that we've already talked about, like Angular, React, Vue, and Knockout. Wijmo's spec method allows you to determine which framework is best suited to your project based on your priorities. So whatever those priorities and your selections are, you can learn how to migrate to a new framework in this ebook. Best of all, this ebook is free. You can download your copy today to help choose a framework for your work at softwareengineeringdaily.com/grapecity. Thanks to Grape City for being a new sponsor of Software Engineering Daily. You can check out that ebook at softwareengineeringdaily.com/grapecity. Right. So like distributed tracing, for example, seems like something where this is a relevant conversation to have, because distributed tracing you want over all of your services. Like, I can't think of a reason why you would want a service not to have distributed tracing. So how would that fit into this conversation? Like, is there some well-formed integration that you would do? I think just as an example of something that you would use Istio for or use a service mesh for, does distributed tracing fit into that example?
Yeah, I think it does. Distributing tracing it's a complex problem for people to solve well, and there's a couple of different issues that you need to address. I broadly categorize those as kind of instrumentation and then triggering. On the triggering side, what you really want is to be able to control, when and how traces become initiated. It can be very expensive to have tracing on all the time. It can produce far more data than you would be willing to actually store, and it can severely impact, how much data is flowing over your network if you're gathering very, very detailed traces for every small operation that occurred. It might not be a good idea, for instance, to enable distributed tracing for everything that was going to make 1,000 calls to Redis. That would probably be a bad idea. So triggering is important. You want to be able to control when it occurs, how often it occurs, and that's something that Istio can definitely help with, right? Because we control, the ingress points into the mesh, the traffic between nodes in the mesh, we can have operators define triggering policies that apply across the fleet. And we can standardize the mechanisms by which triggering occurs so that you don't have to go and write custom triggering code in different applications. So that's one area that we can help with significantly, and that is actually a very, very important concern.
Okay.
The second part, instrumentation, we can help a little bit. Ultimately, some of the things that you're going to want to trace occur inside applications themselves. And so there are libraries that exist in runtimes that help with that problem, Zipkin being a pretty good example of that, but there are others. And there are standardization efforts out there like open tracing and others that we are supportive of. Mm-hmm. What Istio can do, while we can't actually modify or enable, tracing of behaviors within inside the application, we can at least make sure that as those traces propagate down through the system, that we enrich them with context that we have in the mesh that you wouldn't have to go and alter your application code for. So, we can make sure that we're accurately and reliably layering in information that we have about the communication that occurs between services to make sure that those traces have a good level of detail in them. And we can do that augmentation both as the traffic flows through the system, but also at trace capture time, right? Ultimately, in distributed tracing systems, nodes within the graph are reporting, trace spans into some centralized system for later storage. One of the things we can do is basically capture that event and do enrichment there, even for traces where we weren't in the network path. Because we know a lot about the topology of the network, we can make sure that we are pushing some of that information into traces that were captured by applications themselves. So those are the kind of two basic points of value add. Of those two, I would say, uniformity around triggering is probably the most important thing. The last thing you want to have is you roll out an application to production and then realize that you need to enable or trigger a trace after the fact, but you have no way of doing it. That would be a pretty terrible outcome.
I want to spend a little more time talking about the deployment and topology of Istio. So if I've got my Kubernetes cluster, I've got a bunch of containers running in pods somewhere. We've kind of gone over in detail the idea of a sidecar, these Envoy sidecar service proxies that are talking to each other. Talk a little bit more about the control plane, which is this centralized entity that can do lots of things. It can synchronize different things, can aggregate different things. And talk about the relationship between that data plane and the different sidecar proxies that are aggregating this information.
So, you've deployed Istio, you've created a service mesh, you now have all these applications running. And what you really want to be able to do is, as an operator, is to be able to affect changes in how traffic flows through the network without requiring, people change those applications, right? That's maybe the thing people think about first when they think about service meshes. And so you need some way of managing the configuration of that. So we provide a system to do that.
Sorry to interrupt you, but you mean like without doing a deployment? You say you
without,
want to be
without having to redeploy or update application code. Yeah.
Right. So you want to change an application, but you don't want to do a deployment. You can use Istio.
Right. So a great example would be something like A/B testing, or migrating traffic from a legacy service to a newer version of that service or to some other vendor. These are things that you want to be able to experiment with without really having to radically change your deployment architecture. And Istio gives you the kind of fine-grained traffic controls to say, look, I want to siphon off 1% of my incoming traffic and send it to this alternate backend to qualify it for release management, right? So we're talking about canary deployment scenarios.
Mm-hmm. Yeah.
That's a very kind of maybe the canonical example for, service mesh traffic management. Other examples might be, you want to change how you do load balancing on the fly because you're having service availability problems. Maybe you do need to stand up another cluster or some more instances, or, do something else with regions. And, all your incoming traffic or all services going between traffic is currently going to one location, and you need to make sure it goes elsewhere because you're having stability problems. So service mesh would help you do those types of things, again, without having to change all the clients in the network. And so there's a lot of scenarios, we've had experience with at Google where, you have traffic imbalancing and you need to be able to react to it quickly. And, rolling out application changes is the exact opposite of doing something quickly from an operations perspective.
So is the data plane polling the different sidecars, or what's the strategy for aggregating information?
Well, so when you say aggregation, so typically, there's pushing out changes down into the service mesh, which effectively means making a configuration change to how traffic is supposed to flow, and then distributing that to all the proxies in the mesh that need to be aware of that change. That is effectively done by the proxies polling for that information. Similarly.
I see. So the proxies are asking the control plane, "Hey, what's the policy right now?"
Right. Yes. And we try to do that as efficiently as possible because the mesh could be very large. Like you could have tens of thousands of proxies asking those types of questions. You need to be able to scale up to that. And similarly, the proxies are also providing feedback to the mesh. Right. As traffic flows to the proxies, it's observing whether API calls are failing, is latency spiking, those types of things. By collecting the telemetry and feeding that back into the system, you can drive things like horizontal autoscaling. We haven't done this yet with Kubernetes, but we absolutely plan to provide, standardized metrics about pod scaling latency requirements so that you could horizontally autoscale pods based on latency instead of just CPU consumption, right? Which is pretty important for services that have specific types of SLAs. Right, so that's information flowing in the other direction, basically observing the behavior of the data plane and using it to control either routing and or scaling of deployments themselves.
So typically, to make it even simpler, right, all of the service proxies, envoys in Istio have they're obviously talking to the control plane in both directions, as Louis said. From proxy to control plane is pretty simple and standardized API. You're either asking for a check or a report. So you're either saying, should I allow this traffic or not based on all the policies? Or you're saying, I want to, report all the attributes and what's going on. So that's the proxy to control plane. And the other way, which once you are observing everything, you can start doing. We haven't done those, but those are, more interesting things we can get into in future releases.
So I've done a couple shows about Prometheus, which is this distributed monitoring tool. It's based on Google's Borgmon. So Kubernetes was based on Borg, Prometheus was based on Borgmon, and some of the techniques that we're talking about here sound somewhat similar to the problems that Prometheus is trying to solve. Can you talk about a comparison between Prometheus and a service mesh?
Prometheus is primarily just, at least the way we look at it, is one of the possible sort of monitoring visualization tool, right? Prometheus I would put under the bucket of sort of monitoring and visualizations and everything upstream on top of alerts, etc. on top of that. The way mesh is more runtime in terms of what gets injected into with your applications to actually and be in the runtime to collect signals that you can decide to put into Prometheus or some other similar system, variety of those in commercial space. So that's a distinction I see.
Can Istio do the job, do some of the work that, or maybe the Envoy sidecars, depending on what part of Istio you want to talk about, can it do some of the work of handing off information to Prometheus? Maybe you can talk about if there's any synergies there.
That's exactly what we are sort of doing. So what Istio is doing is...
That seems quite useful.
Yeah, I mean, our current release is basically signals from Istio flowing into the Prometheus tool where you can start to see graphs around QPS and error rate and latency from service to service. Really sort of application L7 level metrics that you would like to see when you're holistically, right? And over and above all of the L3, L4 CPU resource utilization metrics that you already see. So the way I see it, we are enhancing the kinds of metrics that you can see in Prometheus or any other similar system. It's exactly one of the things that people want when you're running large, when you start splitting and having it into large microservices, is really getting that confidence that my latencies by breaking things apart is not killing me, right? And having those signals given back to you. The other thing I would add is, which is, when you do traffic management things, especially like A/B testing, staged rollouts, you also want instant, as quickly as possible, feedback. So if I just roll out N% traffic from A to B to a new version of B, you want to get the confidence about the latency for that N% traffic is under control. So as you do these rollouts, that's where I think the policy piece ties in with the metrics piece, and there's more interesting things we can do there.
Yeah, so this kind of brings back to something that I wanted to touch on. The one thing that Istio offers above anything else, or service meshes in general, is they offer some uniformity across the entire fleet for these metrics. As Varun mentioned, Kubernetes and other things they give you uniformity for, network bytes in and out, CPU and RAM consumption. But when it came to metrics about L7 behaviors, you were kind of at the whim and mercy of how well a job any given application in your fleet did integrating telemetry. And so if you have gross inconsistencies in telemetry across the fleet of applications that you're observing, it's very hard to reason about behavior. It's very hard to plan change. It's very hard to manage rollouts, to do all these types of things. And so having the ability to enforce some uniformity is really what allows the operator to make decisions. And, if I had to say, through my experience working at Google, the thing that most struck me when I was managing production systems was how uniform the metrics were about service behaviors and how important it was to be able to get that information to make decisions.
Artificial intelligence is dramatically evolving the way that our world works. And to make AI easier and faster, we need new kinds of hardware and software, which is why Intel acquired Nirvana Systems and its platform for deep learning. Intel Nirvana is hiring engineers to help develop a full stack for AI, from chip design to software frameworks. Go to softwareengineeringdaily.com/Intel to apply for an opening on the team. To learn more about the company, check out the interviews that I've conducted with its engineers. Those are also available at softwareengineeringdaily.com/Intel. Come build the future with Intel Nirvana. Go to softwareengineeringdaily.com/Intel to apply now. I worked at Amazon for a while, and I had a similar. I mean, I probably didn't operate things at the level of sophistication or authority that you did, or that you have. But I was kind of blown away and impressed by the fact that there was standardization. I mean, they were able to impose standardization by offering. I mean, it was something similar to a sidecar, and this was before there was a lot of open source attention around this kind of infrastructure. It was just it's fun because it's you work at one of these companies, you really do get to see the future of infrastructure before it gets released to the open source world. Because I was seeing it, I was like, wow, what is this? This is mind blowing. This is magical. But now I'm reporting on it. I kind of understand. Oh, okay, it's this thing. I mean, it's very impressive, but it's a little demystifying.
Right. Yeah. I mean, the goal is obviously to bring a lot of that capability to the community in an accessible and easy to consume way. Right. One of our goals in Istio is to be able to have people turn on Istio without having to do anything to their application, right? Without having to rewrite it, without having to do any of those things, and to get this information out. And once you can get that information out easily, then you can start to appreciate the value that it brings, and you can start to rely on it and make operational decisions based on it. I'm sure that was your experience with Amazon. If you were trying to decide how, do we need to scale this service up? How many more instances do we need to bring up to meet our SLO? All those types of things. This really, really helps with that problem.
It does, and I would say one reason it helps is because it reduces the friction to doing X. If X is add some servers or do some better load balancing or do a canary deployment or something, if part of that decision is how long is it going to take me to actually do that, or how many hoops am I going to have to jump through to figure out how to do that, it's a little more annoying, and it creates some bias towards not doing something that you should do. So there really is a lot of importance with this ease of use, and I know that I think part of both your goals is to get Istio well integrated with the platform as a service offering, like the Google Container Platform as a Service offering, the Kubernetes offerings, I guess, of different platform as a service flavors, getting it to that kind of a one-click glory, easier use. I want to talk about kind of the higher level, both the open source community and closed source platform as a service stuff. But I guess before we kind of shift the conversation to talking about this broader ecosystem, if there's somebody listening right now and they are a developer, they've got a Kubernetes cluster, they work at a company that has a Kubernetes cluster, I guess just put a capstone on the conversation that we've had so far. What are the technical problems that this type of developer might be having where they should look into Istio? They should consider it even at the sort of, nascent, it's not nascent, but this kind of 1.0 release, or I don't know if you're at 1.0, but the state of Istio today, what kind of person should be looking into Istio?
I would say everybody, and I don't mean to be facetious there. You could almost think of Istio, in the context particularly of Kubernetes, as just a bunch of networking tools that help you, make your applications, your distributed applications, more reliable to build, right? So that's probably your first port of call. You've done some stuff with Kubernetes, which probably means you're doing something microservice-y-ish, or we actually don't care how micro your services are, and so you're trying to figure out, am I going to go and put a whole bunch of retry logic into my code because I know the application fails, or the networking is going to have failure modes and I need to deal with those, or maybe you're not too concerned with that problem, but you are looking around how am I going to do APM, right? How am I going to track, the behavior of my applications on the network? Am I going to have to start writing a bunch of instrumentation code? You might find it a lot easier and cheaper just to go and turn Istio on and rely on its kind of automated instrumentation mechanisms to get a pretty holistic sense of what's going on in your network with a very low, investment. So, if you're at this kind of nascent stage, that's what should be motivating you, right? Is that you don't have to make a large investment to get a very significant amount of value back out. Once you've done that and have gotten used to the concepts and have gotten used to the extra value that stuff is going to bring, then you might want to start looking at the additional value that we think applies to deployments as they mature, right? Where you want to start having some more policy control. But your first port of call should be, hey, I need observability. Observability can be hard. Here's how I get a whole bunch of it, and in a really consistent and fairly well-designed way for free, effectively.
Okay, so I hear the bell tolling with our calendar invites for 10 minutes away. So I'll be crisp with your time for the remaining questions. So one thing I find interesting and sometimes confusing is the boundaries between what problems Kubernetes should be solving and what problems the open source, the other open source projects, perhaps the Cloud Native Computing Foundation projects should be solving. How do you guys look at those boundaries? I mean, why shouldn't Istio, for example, be in the purview of Kubernetes? If everybody in Kubernetes should be looking at these issues and perhaps considering bundling them into their Kubernetes cluster, why shouldn't this problem be solved within the Kubernetes project itself?
I think that there's a simple answer there, which is all of the concerns mentioned that Istio addresses, mentioned in our conversation, pretty much exist maybe in slightly different flavors, even if you're sort of running in VMs or bare metals or other orchestration environments, right? So the problems around inherently making applications more reliable without doing, all of the heavy lifting in code, about consistent observability, security, everything that we mentioned, they are applicable everywhere, right? So that's sort of the reason of why not just in there, although, our first target environment has been Kubernetes, and, depending on community response, we may see more and more of, Kubernetes plus Istio deployments than just Kubernetes deployments. As Istio project, we would like to give the capabilities of mesh to, wherever you're running. Of course, we would like more and more people to be running on Kubernetes. And in fact, I think mesh can even help in that journey of you moving to Kubernetes, and we would like to help there. But, it's going to be a process, and there's lots of workloads running outside Kubernetes as well.
Mm-hmm. So I did a show about Linkerd recently, which is another service mesh that's built in this space. And this raises the question, another boundaries question. So in this open source ecosystem, there are different players that have some overlapping functionality. And sometimes that overlap could be complementary. For example, I think the Prometheus and Istio overlap. It sounds like Istio can solve some of the problems for Prometheus, and that's a way that's harmonious. There are other places where there seems to be some conflict. How do you guys assess that, diplomatically, when there are projects with overlapping functionality?
So I think there's a variety of things. Linkerd and Istio are, they overlap in some areas and they don't overlap in others. And, in the areas that we don't overlap, we can actually be complementary to each other, particularly with regard to some of the policy stuff that we talked about earlier. So, there's definitely potential for complementary development there. In the kind of the nitty-gritty details of networking and data path, right, we are directly overlapping, maybe not competing because, maybe people view these products slightly differently or have placed different requirements on them. But, I've certainly seen the same question. Envoy, which is the sidecar proxy that we use, and Linkerd, which is the sidecar proxy that the Buoyant guys developed. And, there are other folks out there using HA proxy or Nginx or homegrown stuff to do these types of things. We view that as one, market validation, but also, having a healthy ecosystem and healthy competition will probably help us, thrash out the requirements and make progress more quickly. From my view, ultimately, proxies should become a commodity technology that as long as a proxy is providing you the features that you want in a performant, scalable, and reliable way, then if you move between environments, and you happen to get a different proxy when you move to another environment, that things continue to function and that there isn't divergence. And that's what's most important, right? So if you were running your workload in Kubernetes on-premise and then you move it over to Google Cloud Platform or IBM Bluemix or something like that, that things keep working, even though the cloud vendor is now managing that behavior for you, right? I think that's what people really want, right? Is they don't want to deal with divergence, and they don't want to pay too much for it as well. We chose Envoy because we thought it represented a good mix of features and performance and reliability and community, which is why we've made a strategic bet on it. But we don't see everybody agreeing with that in all scenarios. But what we do want to try and do is work with these other folks to try and come to some agreement around common behaviors and things like that, because that's ultimately what our customers want.
All right. Well, guys, I want to thank you for coming on Software Engineering Daily. I know we just had some struggles getting the show organized and orchestrated, and it's the middle of the afternoon. You guys are both in the midst of busy days, but if you have something in the future, if you guys want to come back on, I'd be happy to have you. This is a really interesting subject, and I know we barely scratched the surface, and this whole area is moving so quickly, so I'm sure we'll have something to talk about in a month, if not a week.
Yeah, next week. Yeah. No, I would certainly be more than happy to come back on. Yeah, this space is moving very quickly. Yeah, so we're busily trying to keep up with it ourselves, and so we know that it might be a struggle for the community out there to kind of keep tabs on what the major trends are and what they should be paying attention to. So we want to stay in touch with people, and I think this is a great vehicle for doing that.
It is multicast.
And thanks for having us. Gives us a channel to let people know what's going on. So thank you.
Absolutely. Okay, well, thanks, guys. You have a full-time engineering job. You work on back-end systems or front-end web development. But the device that you interact with the most is your smartphone, and you want to know how to program it. You could wade through online resources and create your own curriculum from the tutorials and the code snippets that you find online, but there's a more efficient option than teaching yourself. If you want to learn mobile development from great instructors for free, check out CodePath. CodePath is an 8-week iOS and Android development class for professional engineers who are looking to build a new skill. CodePath has free evening classes for dedicated, experienced engineers and designers. I can personally vouch for the effectiveness of the CodePath program because I just hired someone full-time from CodePath to work on my company Ad4Prize. He was a talented engineer before he joined CodePath, but the free classes that CodePath offered him allowed him to develop a new skill, which was mobile development. With that in mind, if you're looking for talented mobile developers for your company, CodePath is also something you should check out. So whether you're an engineer who is looking to retrain as a mobile developer, or if you're looking to hire mobile engineers, go to codepath.com to learn more. You can also listen to my interview with Nathan Esquinazzi of CodePath to learn more. And thanks to the team at CodePath for sponsoring Software Engineering Daily and for providing a platform that is useful to the software community.